worst come to worst, check this just to see that. Yep, that's what it was. I was playing on YouTube as well. Which, while that sounds great, it's a little distracting, at least for me. So, we will go ahead and get started. Yeah. So my hope is that your breaks were going well. I will try to share what I have on screen, and we'll run from there. I'm going to do everything on this tablet just because it makes things a little bit easier to write with. So it's going to say my note, but it's a little different. Okay. So let's go here. And let me go ahead and share my screen so you guys can see what it is I'm talking about. All right. So right now you should be able to see what's going on the screen. And as promised, today is all about redox. So let's look at a couple of examples, one of which is going to come directly from one of the sheets that I gave you, and then the rest will follow on from there. Live link. YouTube page. Look for live events. Sorry. Trying to get a message out to those who might still be wondering what in the world is going on, just in case. Now, the example that we're going to go ahead and start with is actually going to be for the reaction. Sorry. It is MnO4 minus plus I minus, sorry, is going to yield for me I2 or iodine plus manganese dioxide. Now, with this equation that we're looking at, we're going to have to break it down into the two portions, half reactions and so forth. So let's jump in. Looking at the fact that I have a change from MnO4 minus for permanganate ion, and it's going to be changing into MnO2, and we have I minus, which is going to be transitioning into I2, which is again iodine itself. Actually, let's stop this for just a moment. Type a comment. I want to pull something up. I apologize, guys. I want to pull up a page just in case, so anybody who may be sending any types of comments or questions, we can go ahead and get that taken care of. And right now I can't see that for whatever reason. So Okay, got 2 viewers now. See if I can pull up links to this directly. Because again, I know this was kind of a last minute and things got a little shit, but we'll try to make it work the best way that we can. This way, if you ask any questions directly on page, no, it's not. Um, this way, I can actually get those comments directly. Now, this is going to be on the worksheet that I gave you guys originally, which had the how to balance in acidic and basic equation reactions. Sorry, solutions. So let me see if these will come up. Yeah, it's not coming up on where I originally had it, so I'm going to adjust that so you guys can see. All right, now let me go ahead and share my screen again. Try this one more time. Share. Okay, so again, this is from the work redox reactions in basic solutions. So we would normally break this out just as we've done here to look at the differences in the amount of manganese and so forth, sort of a way of balancing out the equation as it would normally be. Now, the thing that we're going to have to consider here is we're going to balance the equation, but then we're also going to balance out the charges overall, and this will make things a little bit easier as we work. So if we're looking at this equation as is, I'm going to start off with my first part. Our just our actual species. If I'm looking at it to balance it out, I have two more out here than I have on this side. And yes, I haven't gone into the electron part just yet. Just hang with me. So the first thing I'm going to do, just like we were doing in the acidic solution, I'm going to add water to the other side, and I'm going to rewrite this a little bit lower. So MnO4 minus yields MnO2, and I'm going to add 2 waters to this so that we can go ahead and take care of it. So 2H2O with, if that's the case, then that means I have to have 4H plus on the other side to cancel that out. Now, in your head, you may be saying, Mr. Baldwin, why are you adding hydrogen? This is a basic solution. Well, this is the thing that we have to consider. When we deal with a basic solution, what makes it a base? The presence of hydroxides. So when we're actually starting this off, we're starting it looking at it as though it's a basic solution, I mean an acidic solution, but we're going to add on one more step, which is where we're going to come up to next. So now that I have my hydrogens balanced, this is where the extra step comes in. Because if I look at this, I don't have any hydroxide anywhere in the solution. So I'm going to, pull it up in this way. I'm going to add however many hydroxides I need to both sides to cancel out these, but also so I end up with a base. So I'm just going to add it below here. So I have 4H plus, so that means I need 4OH minus on this side, and I have to do the same on this side, plus 4OH minus. Now, in doing that, notice that now I've created 4 water on this side. So 4H2O plus MnO4 minus yields MnO2 plus 2H2O plus 4OH minus. Now, my hope is that you're noticing as you look at this that we're going to have some waters that are actually going to cancel out in this. But we haven't done anything so far about the number of electrons. So what we're now going to do is we're going to go ahead and look at the charge on each side now that we have the atoms, the mass part balanced. If I look on the left side of my equation, I have a -1 charge. That's the negative that's coming from our permanganate. If I'm looking here on my right side, I have 4 hydroxides, which means I have 4 negative on this side. What I'm going to do is I'm going to add electrons to the side that's more positive so that I can get it to equal out. In this case, what's the only way to do that? I have -1, -4. That means I need to add 3 more electrons to this side. So, plus 3E minus. This will allow me to balance out my charge overall. Okay, so now with that portion done, I'm going to move on to the second equation, which we can see is a lot easier. It doesn't have any oxygen or anything to deal with so far. If you run into any questions, please add them to the chat window on the live event. That way I can actually answer them and make sure that I'm not leaving anybody behind. Now, if we look at this one just as it is, I'm going to go ahead and I need to double this because I have 2 iodine there, 2 iodine here. In the change from this side, I'm following the same exact thing. Once my mass is balanced, balancing out the charges, I'm negative here and nothing here. So that means I'm going to add 2 electrons to that side. That will balance out my charge for that one. Things are great. Now, hopefully by now you should notice that, okay, although everything looks balanced, our number of electrons isn't, and that's where our problem's going to come in. So we need to go ahead and make some quick changes. We need to multiply everything by a couple of numbers so that our electrons will equal out. We have 2 and 3. So the number we need to get to is 6. So take my equation here, and I'm going to go ahead and multiply this one by 3, and take this whole thing here and multiply it by 2. In a moment, I'll probably have to change pages, but my hope is that you're writing this down as we go. Oh, now up to 4 viewers. Welcome in those who are joining us. Okay. Now, good question, Ray. Looking at it, it says, you said, why do we add the hydroxides? Well, remember, this is actually balancing in a basic solution. Since we're dealing with a basic solution, what do we have to make sure is present? You have to make sure that the hydroxides are there. So, and Ayana joined right in with that actual answer. Thank you for chiming in on that, Ayana. Now, as we're taking a look at this, everything would be, again, up to normal until, okay? Now, let's take a look at what we're going to have for our, sorry, other questions just came in. Great. Ria, reason why we added 3 electrons, we were trying to balance out the charge. If we're looking at this overall, notice we didn't actually put up our oxidation states. We really just looked at, I'm going to answer your question in a moment, Ray, sorry. We had to balance out our charges. Once we followed our law of conservation of mass, we knew that there was going to be a difference in charge. So we have to look and see, okay, what is that difference? Okay, notice that the half reaction method and the oxidation state method, they can come up with the exact same thing, but in certain situations, one works better than the other. And this is what we're using here. We're actually using the half reactions. So when we looked at it overall, we had -1 on this side. Sorry, we had -1 on this side, but we had -4 over here. We want to make sure that the side that is more positive, we can equal it out. And the only way to do that is by adding 3 electrons to this side. Now, Ray, to answer your question, why add hydroxide to both sides? As we look at it, for it to be an acidic solution, we just need to make sure we have the presence of hydroxide, period. We're not going to end up with it on both sides though. As we can see, we had our 4 hydrogen ions, but that's not what we need. We need it to be basic. So we add the hydroxide so they'll neutralize out our hydrogen ions, but we'll still be left with a hydroxide making it a basic solution. Does that make sense? It's on the right side. Sorry, it looks a little weird right here. That was my 4. And again, I'm trying to take my time with this tablet, so it's a little bit, my handwriting can be a little bit more legible, considering we know the usual. But do we all have this written down? If somebody can come in and let me know that we got this written down, I can go ahead and change pages and hopefully make it a little bit more legible as we go. Is that a yes or no? Oh, or maybe a writing. I'll give you a couple seconds. Okay. I'm going to go ahead and continue on to the next page. Okay. Now, with each part of this already multiplied and balanced, sorry, not multiplied and balanced, but multiplied, I'm going to end up with, here we go, 6 E minus plus 4 H2O Hold on, sorry, I feel like I'm looking at the wrong thing. No, 4 H2O plus 2 manganese permanganate MnO4 minus is going to yield 2 manganese dioxide plus 8 OH minus. And then we're going to go ahead and take the next part, which is the other part of the equation, multiply it by 3. So, 6 I minus, which is going to yield 3 iodine plus 6 electrons. Just as we did before, we need to cancel it out. And then that will actually give us a place to start canceling these. So 4 H2O plus 2 MnO4 minus plus 6 I minus our iodide ions, is going to produce 2 manganese dioxide plus, sorry, 3 iodine molecules. Any questions? Okay. Is there one that you all have? Why is only 4 hydrogen? Where do you get 4 hydrogen? There are 4 waters. Okay. If we're taking a look at it, remember we had the 4 hydrogen ions and the 4 hydroxides. If we put those together, they're going to form water. So that's why we end up with 4 water molecules here. Does that make sense? That's the whole reason why we actually put the hydrogen ions in. Eventually they're going to cancel out and we end up with that same water that we were going to deal with before. Questions, comments, or concerns? Okay. I have another one that is in front of me that I'd like to go ahead and attack, but I want to check and see if you all have any that you wanted me to go through from your assignment. Unfortunately, I don't have a copy of it here in front of me, but if you could quickly like give me the reactants, then we can go ahead and start looking at it and work through it. If not, I think I have another example that we can run to. I realize there's a slight delay, so I do apologize for the long pauses sometimes between. Okay, I've still got no response, so my assumption is we're good. On that front, I'll go ahead and attack another one. On my side, I have a couple of examples to work from. Just wanted to check and see, did any of you get a chance to go through the Solution Stoic video that I posted earlier this week? Oh, there we go. Ionic threw one out there. Can you do HCl plus potassium dichromate? And we're going to look at again how things are going to work. Well, overall, let me write it down on a sheet of paper on this side so I can go ahead and switch screens. Okay, so HCl plus K2Cr2O7 Okay. Coming up. All right. So we have a nice long one that was given to us by Iana. And let's see. Trying to see where my screen went. I apologize. There we go. I'm gonna go ahead and change the screen, the page again. All right. So Ayana gave us one that she wants us to go through is HCl plus potassium dichromate is going to yield KCl plus water plus chlorine. Okay. Now, taking a look at this, the first thing we need to figure out is what, oops, I forgot a product. I forgot about our chromium chloride, chromium 3 chloride. Okay, now the key that we're going to look at here is the first thing we need to do is we need to get rid of all of our spectator ions. So just as we would do before, we want to go ahead and if it's the same on both sides, we're basically getting rid of it. So we have HCl, which we know is going to ionize, so we're going to end up with two of our, we have Cl minus, sorry, plus our dichromate, Cr2O7 minus 2, which is going to produce, sorry, we have Cl minus coming from here, plus H2O, Cl, chlorine, and Cr3 plus. Now, the thing that we want to consider here is that it's not just going to be a situation where only one thing is oxidized or reduced. Ray, I see your question that came in on there too. So we'll try to go through this one and then we'll move on to the next. Now, if I'm taking a look at this, I have this chloride, which it looks like it's the same on the other side, but we also have chlorine showing up in two different locations. We still are going to have the change as we go from chloride, Cl minus, to our chlorine gas. Okay. Now it does show up in multiple places, and that's perfectly fine. But that just means that in one place it's acting as a spectator, and it's also going to be lumped in eventually. The second thing we have to consider. Oops. Sorry, I didn't mean to write on those. Okay. So go ahead and fix our 2 there. Okay. Now, the other thing that we're going to consider is what's happening to our chromium as we go from this state over to the other. So let's go ahead and actually start with this. And I'm going to end up with 2 of those to balance it off, and plus 2 electrons here. Why 2 electrons? I have the actual atoms balanced, the mass. I'm going to have to balance out the charge. With our chromium, we go from Cr2O7 to minus 2 over to Cr3 plus. Still in a basic solution. I'm based on what you all have shown me. So let's go ahead and jump into it. If I have 2 Cr both sides, that would help me out here. And then I'm going to go ahead and add water, just as I did before, to balance out my chromium or my oxygen from the other side. I have 7 oxygen, so that means I need 7 water molecules. Now that I have these 7 water molecules, I need to have hydrogens on the other side. And this is also helped by the fact that we had these hydrogen ions given from our hydrochloric acid. So, sorry, I apologize if that was a little loud. I'm going to end up with 14 H plus ions. Now, in doing this, this again takes care of making sure I'm balanced mass-wise. But since we know that it's in a basic solution, that means we have to have hydroxide on both sides to cancel out the hydrogen ions. So if I have 14 hydrogen ions, that means I also have to have 14 hydroxides. Youch, that's a lot. So with 14 of these, this also means I have to add it to the other side, plus 14 hydroxides. This is going to cancel these out, but leave us alone with this part. If any questions so far, please let me know. Okay, wonderful. So that's going to go ahead and cancel out my hydrogen ions for both sides. That gives me 14 water plus our dichromate. And I'm rewriting this because I know my handwriting is very interesting. Cr2O7 minus 2, 2Cr3 plus 7 water. Question was asked, well, actually, every time you add hydroxide to one side, you have to put it the same amount on the other side? Yes. Think of it sort of like a math equation. What's done to one side, you have to do to the other. And I realize there's a little lag again, so if I'm answering it and you see the answer come up again, just bear with me. I hope that it'll work out to make sense in the end. So I've now finished off this part of the equation, except, of course, you're probably looking at it and saying, okay, you have 14 water there and 7 there. You can't have it on both. I will try to write a larger array. I apologize for that. See if I can get a larger page somehow. I don't think it's going to allow me to do full screen like that. Okay, so you only cancel out the hydrogens. The hydroxides, you leave the other. Yes. And the reasoning behind this is that it's going to allow me, it's still going to be balanced mass-wise, and that's what we want to make sure. We're still going to be following the law of conservation of mass. So let's go ahead and take a look at the next part. If I'm taking a look at here, I can get rid of I can go ahead and get rid of 7 of these. So I'm going to end up with 7 water plus, sorry, Cr2O7. It's going to yield 2 chromium 3 ions plus 14 OH minus. Now, with this part being done, all I need to do is simplify my equation. Oh, nope, I haven't dealt with electrons for this one. I apologize. I have a -2 here, and oh boy, a big change on this side. I have 14 minus on that side. So I'm going to add to the more positive side however many electrons to get things to balance out. So if I have 14 and -2 here, that means I need to add 12 electrons here. So let's take a look at what we have. I have this, which is going to stay just as it is. And I have this, which I'm going to have to multiply to get 12 electrons. Multiply by 6. So I have 12 Cl minus, which is going to yield 6 O2 plus 12 electrons. And I'm going to simplify that with my 7 water plus our dichromate to chromium 3 plus I'm answering some of the questions via text because it seems like it goes through real time. Again, I apologize for the delay between the two. Again, the goal is that the question I was asked was, where did the 12 electrons come from? And again, answering, we have to balance out the charges for both sides. Because I had the 14 hydroxides on the other side, that means I have to have 12 electrons added so that my charges will work out the way that they're supposed to. So now we're here. Oh yeah, it's finishing writing the equation. That's Cr3 plus, not C strange thing. Cr3 plus, and our 14 hydroxides. If we cancel everything out, see if it'll let me undo that. There we go. Cancel out what cancels out, which the only thing that would cancel out would really be the electrons, which were on this side. I apologize, forgot to write them in there. Everything is going to go just as it is. So 12 Cl minus plus 7 water plus our dichromate which is going to yield our 6 chlorine plus 2 chromium 3 plus 14 hydroxides. Questions that may come up. For those who might be having difficulty seeing, I am adding it into the chat window just so it's a little bit clearer. And anyone who may come back to look at this later can actually just look at the chat history, and they should be able to see it as well. 6, 2, plus, OH. Oops. Questions that are might be going around in your head? How do you put this into the original solution? You would actually balance it just the same way. When you write your equation or your finished product, you would write it in this way because we're usually concerned mostly with what changes, not necessarily the extra stuff that comes in, the spectator ions and so forth. This is sort of like writing your net ionic equation for this reaction. Again, the potassium is just a spectator. Let me go ahead and switch over so you guys can see me. I'll know that things sort of switched over in just a second. But again, all we're looking for here is what is the change. We're not concerned with the spectator ions that are just floating there in solution. They're not going to do anything for us. And so we want to make sure that we're keeping this all together. Yes, that's how we were able to tell. Rhea asked the question, were you able to tell the spectator just because it's on both, because it's not on both sides? It actually was originally on both sides. It was in the potassium dichromate, and then on the other side as potassium chloride. So we want to make sure that we're keeping track of what we originally had as well. The only difference is here I didn't go through and do the whole complete ionic equation, and that might be why people are thinking that it might be missing. Sorry, again, breaking in me talking because I was answering the questions. But we're looking at a couple of questions came in, just dealing with determining the spectator ions. We got those, I believe, taken care of. Now, there's another question that also came in while we were originally looking at it. I believe it was from Ray. So I want to see if I can go back to that question. There we go. I'm going to go ahead and write this one down while I wait for any other questions that might be coming in. FeCl2 plus potassium permanganate plus HCl according to what I'm seeing here on the page, and I just thought about this and just connected this. As I'm looking at both of these examples that were given, the equations actually say that they were in acidic solution. So we could actually stop that problem a little bit sooner, mainly because we have HCl, strong acid, in both of the examples that were given. Does the paper specifically ask for it to be balanced as though in a basic solution, or does it just say balance it? The oxidation state, let's see, question came up, but so did hydrogen and chlorine and chromium. How do we distinguish it? If I'm taking a look here, the chromium did change. The chlorine also did change. Their oxidation states changed. That's why we also, but that's also why we did not include both chloride ions that showed up on the other side. If we were to pay attention to that part, you notice that we had some that formed into chlorine gas, and we had some that also went into the chloride that was attached to the chromium. Taking a look at this, both of these examples that you guys actually gave me are in acidic solutions. So that could be where some of the confusion is coming. And it just connected, and I do apologize for that. I'm taking a look at it, and I'm seeing HCl in both. HCl is a strong acid, so I should already know that it's in an acidic solution. Are there any questions on those that you guys have that are in a basic solution? And I believe the worksheet specifies it exactly. I'm going to go back to this screen in a second. If I'm taking a look here, I didn't have to go through the whole mess with the hydroxides here, simply because the HCl was my acidic, I guess, message, we'll say. If I were to go back, that would actually make that one a lot easier to work through, because I'm getting the hydrogen ions from there. So it'll be just as we've done it before in class. Robert, just saw you come in there. Just want to make sure we're good to go. Does this one actually specify basic? I want to make sure that way I don't take us off in the wrong direction. Okay. All right. So let's go ahead and take a look at this one. We're given S2 minus plus our permanganate ion is going to produce sulfur plus MnO2. Okay, so we're looking at the changes. We have sulfur 2 minus, or sulfide ion, that's being changed into sulfur itself. And then we have our permanganate 4 minus, that's being changed into manganese dioxide. Okay, now because this one specifies, and it sort of works with one that we've already done, so that actually works out perfectly. We're still going to follow the same steps. First off, balancing out. In both cases, we have our number of atoms except for our oxygen in the second one that are taken care of. So I'm going to add 2 water. Now that I have my 2 water, I need to make sure that I also add in, my hydrogen ions to balance those out. So 2 water, 4 hydrogen ions. Now, because of the fact that I have each of my hydrogen ions already in position, things are moving great there. I now need to make this a basic solution. So I'm going to add hydroxide to both sides. Why am I adding hydroxide again? I want to cancel out these hydrogen ions. So I need to add 4 hydroxides here and 4 hydroxide here. Sorry about the coughing, guys. I do apologize. And Ray, I will get you a question in just a moment. But it's dealing with an acidic solution. That's why I wanted to take a moment for this one. Now, I added in my 4 hydroxides here. Not just 1 hydroxide, but 4. 4 hydroxides to both sides. This is going to cancel out my hydrogen hydroxide here. I get 4 water plus MnO4 minus, which is going to yield for me MnO2 plus 2H2O plus 4OH minus. Now, in doing that, Again, we're going to notice I have 4 here and 2 here. I can't have those show up on both sides of the equation, so I'm going to cancel out these, which cancels out 2 of my water on this side. So that is the only slight change. When it comes to dealing with my charges for both sides, I have -1 on this side and -4 on that side, so I end up again adding in 3 electrons. So this basically ends up being another version of the previous example as far as the first part of the equation. So I'm going to end up having to multiply this one by 2, and this one I have 2 minus here and none over here, so I'm going to have to add 2 electrons there. This one's going to get multiplied by 3, and the bottom one multiplied by 2. So with this one, it will work out just about the same as the first example that we actually did. I'm going to end up with 3s2 minus, which is going to give me 3s plus 6e minus, which is going to give me 6e minus plus 2 water plus manganese, permanganate, sorry, minus, which is going to yield for me MnO2 plus 4OH minus. Yeah, that takes care of that. Add the 2 together. Only thing that shows up on both sides are the electrons. So 3s2 minus plus 2 water plus our permanganate ion, which is going to yield manganese dioxide plus 4OH minus. Now, as promised, I want to go ahead and tackle the question that Ray brought up with our iron 2 chloride being oxidized to iron 3 chloride. And I'm trying to find it because I didn't get it all written down. FeCl3 plus KCl, Mn2, MnCl2 plus water. Now, if I'm taking a look at this equation, my dead giveaway should be that there is hydrochloric acid in the equation. So I have HCl plus KMnO4 oops, I wrote it in the wrong order, but it's okay. FeCl2. And we're looking again at the oxidation of FeCl2 or Fe2 plus into FeCl3 plus, oops, change color, KCl, MnCl2 plus water. And this actually helps you out a little bit because really all you had to do was balance it. It already took into account some of these things. But if we were to write the net ionic, just as we talked about before, H plus plus the permanganate is what we're actually concerned about, MnO4 plus Fe2 plus, which is going to yield Fe3 plus plus Mn2 plus plus water. If I were to break them out into the individual parts, we kind of get an idea of what's going to be where. We have Fe2 plus, which is going to yield Fe3 plus. And we have our permanganate, O4 plus H plus, which we know is going to happen. We just haven't determined how much of them are going to be there. I'm going to save that for just a moment, which is going to become Mn2 plus on that side. So, because of how we would normally proceed, I need to make sure I have the same amount of water on both sides. Oxygen on both sides. So plus 4H2O, which is going to give me 8H plus, which you could have done all of this just as a normal balancing equation. This would be your net ionic. Because it's an acidic solution, we know that because of hydrochloric acid. Let's see. We went from 7 to 2. In order to do that, we had to add 5 electrons to the side. On this one, we lost 1 electron, which means this one is going to be multiplied by 5. So in doing that, we're going to go through 5 Fe2 plus yields 5 Fe3 plus 5 E minus. We're going to cancel out our electrons. Boom, boom, they're gone. Which is going to give us in the long run, I know I changed colors, 8H plus MnO4 plus 5 Fe2 plus is going to yield Mn2 plus 5 Fe3 plus, plus 4H2O. And you should be able to go ahead and input these same values that we just did here in for your previous example or previous part of the example in the full equation, and it should work out to be exactly the same. And again, I'm going to go ahead and input this as a net ionic into the browser so that it can be recalled for future needs if possible, if needed. questions, comments, or concerns? Checking to see if there are any questions remaining. I don't know if it's because of a delay on my computer or if there are actually no more questions. But what I will do is this. This will be posted, of course, via YouTube, so you guys can always refer back to it. If you have any other questions, just go ahead and send me an email. We've already been going at this probably for about an hour and 10 minutes, not a little bit longer. I do apologize again for the lateness of the start, and hopefully I was able to answer your questions. Yeah, so I'll go ahead and end it here because all of a sudden now my computer's starting to do some weird stuff in terms of what's showing up. I hope that it was helpful to you. And again, I'll see you all on Monday. Bring other questions because we're going to spend a little bit more time on it just to make sure you guys are solid. Have a great weekend and see you Monday.